Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 28th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 28 is number spiral diagonals. Starting with the number 1 and moving to the right in a clockwise direction, a 5x5 spiral is formed as follows. It can be verified that the sum of the numbers on the diagonals is 101. What is the sum of the numbers on the diagonals in a 1001 by 1001 spiral formed in the same way? So, a couple of things worth noting here. We can actually start to see a pattern here. So, in the 3x3, it's 9, which is 3 times 3, and in the 5x5, it's 5, which is 5 times 5. So if we want a 1001 by 1001, the greatest number that we're going to end up having is 1001 times itself. So 1001 squared, whatever number that is, we'll calculate it programmatically. And then what we can see is when we start with the greatest number, we subtract 4, in this case, because it's a 5x5, and 5 minus 1 is 4. So if we subtract 4, 1, 2, 3, 4 times, that gives us those next 4 numbers. And then if we subtract 2, 1, 2, 3, 4 times, that gives us the rest of the numbers. So 5x5, we start with 25, we subtract 5 minus 1, or you could think of it as we subtract 5 and add 1, but it's really we're subtracting 5 minus 1. And then we do that 4 times, and then we subtract 2 from the number we're subtracting by, and we do that another 4 times. So 1001 by 1, we start with whatever 1001 squared is, and then we subtract 1000, and then we subtract, so we subtract 1000 1, 2, 3, 4 times, and then we subtract 998 1, 2, 3, 4 times, and so on until we've gotten to the number 1. So it's a relatively simple / clear pattern, I think. But let's find out how well it works to do it as a program. I forgot to commit to my repo last time, oh well. Oops, 1001. Okay, so as usual, we start with our daytime stuff that I like to have because it makes life easier. We're going to create a limit variable once more, and then let's see. So our starting, or let's just call it value, equals 1001 times squared, 1001 squared, And then what we're going to do is sum equals value for right now. And then later we're just going to print that sum. Okay, so while value greater than 0, we want to do subtract by equals, actually this should be the limit. Why did I pull out a variable and then not use it? Limit -1. And then while value is greater than 0, we want the sum to add value minus subtract by What I'm gonna do for right this second is just copy that same line 4 times. That's not a great way to do this. Oh, yeah, actually, this is a really bad way to do it. So what we want to do is value minus equals subtract by, and then sum plus equals value. And we actually want to do that 4 times. Trying to think of a great way to do that 4 times, and again, like, this is clearly a inefficient way to do that, but just so that we know that it works. And then subtract by minus equal 2. So what we're doing here is we're saying as long as the value is greater than or equal to 0, we're going to subtract our, in this case it'll start with 1000, so we'll subtract 1000 from whatever the original value is. We're going to add that value to the sum, and then we're going to subtract it again, add it to the sum again, and do that 4 times. And then we modify our subtract by value by subtracting 2 to account for the fact that our squares keep getting smaller and smaller. And that might legitimately give us the correct answer. And again, while I think that there's some refactoring to do, it should be correct, which is better than nothing. So let's see. It is taking a little bit to run. And we are kind of brute forcing it at this point. Another way of doing this would be to, like, start with 1 and add 2 4 times, and then add 3 4 times. Going back. So if we take this one, if we wanted to sum up 1 and these 4 values, it would be 1 plus 1 plus 2 plus 1 plus 2 plus 2 plus 1 plus 2 times 3 plus 1 plus 2 by 4. So Interesting. So let's see if we can write this a different way after this runs. Actually, it's taking too long to run anyway, so let's see if we can do this. Okay. So what is this pattern that I've come up with here? So obviously we start with 1, and then it's 4 for the 4 ones, plus 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9. No. That doesn't quite work, does it? So 1 plus 2 times 4. Let's do a little bit of maths here. 1 plus 3 plus 5 plus 7 plus 9 equals 25. So if we want 24, that is 2 times 10. So 1 2 plus 2 2s, that's 3, plus 3 2s, that's 6, plus 4 2s, that's 10. So it's like 1 times 4 plus 2 times 10 plus that 1 for the 1 in the middle. And then for this outer layer, 13 plus 17 plus 21 plus 25. That's 76, which is like, again, let's think of it in terms of 1 times 4 plus, so it's 72. 72 divided by 4 is 18. I could have done the math, but I did not want to. And that's 4, and then we have again the 1 plus 2. Okay, so I don't think this is going to work out into the pattern that I want it to be. And this thing's still going. Let's go ahead and kill that. Because I don't think it's giving us what we need. So let's start with value of 1. Add val equals, originally it's just 2. Sum equals value is fine, and then here wall value is less than gigist val. And this is basically the same thing, except I'm doing it in the other direction. Let's see. Add 4 once, twice, 3. Add val times 4. Except it's not really times 4, it's times 10. Yeah, okay, I think I have... So then sum plus equals value times 4. And then at that point, we don't want the value plus the sum. Okay. What was that number that we got before? 76? 13 plus 17 plus 21 plus 25. $76, which is 4 times 10 plus 9 times 4. Okay, so that's the pattern that we want. So for this initial square, it's going to be that. That, and then we have to figure out how to make the value, which is going to be add value is, or value is going to be add val times 4. So, reasoning. So in this first square, right, the add value is the add val is 2, the value is 1. And for to get to 9, we have this add value of 2 times 4, so 8. So 1 plus 8 is 9. And then our add val is just going to be increasing by 2. And then at the very end of it, we're going to end up with, like, I think if we run this right now, we will not get the correct answer, which is 101. So let's go ahead and see that. Okay. I was incorrect. Let's go ahead and do 100 or 1001, see how quickly we get there. See, that took no time whatsoever. Like, literally no time whatsoever between the two timestamps. So, I'm confident that this is at least closer to the way they would prefer us to do this, and it is the correct answer also. So, nice. So yeah, what did we learn? Start at the beginning, do the math way instead of continuously increasing the number every single time. So yeah, I would say that's it for this one, and I'll see you in the next.